Hello, year 11s. Now we are moving on to the last topic in magnetism, which is the application of the two main processes we studied in this unit, with loudspeakers and microphones. So with loudspeakers and microphones done, we will reach the end of P4. So let's move on. So as said in the previous slide, the two main processes we studied in mechanics P4 is the motor effect, and even though it is written here as generator effect, we learned it more commonly as electromagnetic induction. Okay, so and when we did electromagnetic induction, I told you it is the electromagnetic induction and motor effect, they are the opposite. So what happens in a motor effect? A current carrying conductor is kept in a magnetic field. Then what? The current carrying conductor, what does it produce? It produces its own temporary magnetic field. That temporary magnetic field interacts with the permanent magnetic field, creating a force. So that is the explanation of motor effect. Ideally, in simple terms, when current passes through a conductor, it moves. Generator effect is opposite. If you move a conductor, it is able to create a current. Okay. Now, what is the similarity between both of them? Both use magnets that produce magnetic field. And then to summarize the differences I just said, in a generator or in an electromagnetic induction, you move something and current flows in a circuit. In a motor effect, current flows in a circuit, which makes the wire move. So now why are we discussing this again? Because this is what is the working, these are the working principle of the loudspeaker and which is the other one I had said, loudspeaker and microphone, sorry. So these are the working principles of them both. Now we are going to see each one in detail. So the first thing we are going to discuss is the microphone. All of you are aware of what microphones are. Each one of you have that in your phones. You speak into it. Now, when you're speaking into it, you have never thought actually what happens, isn't it? When do we have time to think all those things? We just talk to the microphone. The person on the other side hears it. That's it, right? But then you need to know the physics behind it. So this is how actually the inside of your microphone looks like. So what you see at the left end of the picture there is the diaphragm. So this straight line that you can see here, this bit, that is the diaphragm. So now when you're talking, what is happening? You're producing sound waves. And what is the speciality of sound waves? Sound waves are longitudinal waves. And now what are longitudinal waves? They always move parallel, isn't it? They move forwards, backwards, forwards, backwards. So when you talk, when you are producing sound waves, the sound waves produced by you makes the air particles in front of you to vibrate. And then that vibrations goes and hits the diaphragm. And when it hits the diaphragm, what will it do to the diaphragm? It will make the diaphragm vibrate. And now if you see here, the diaphragm is attached to a coil. So when the diaphragm vibrates, this coil is also going to vibrate forwards and backwards. You can see a magnet, and then this coil is then moving in that magnetic field. When a coil moves in a magnetic field, what happens? The magnetic field linked with the coil changes. And when the magnetic field linked with the coil changes, which effect is that? Think about it. When the magnetic field linked with a coil changes, a current flows through the coil. Which one is that? Electromagnetic induction. So microphones work on the basis of electromagnetic induction. So that is the main working principle of a microphone. So what is happening there? So when the sound waves, they hit the diaphragm, they make the diaphragm vibrate. We have a coil of wire that is attached to the diaphragm. When the diaphragm vibrates, the coil also moves forwards and backwards or vibrates. Now with respect to the coil, since it is moving in that magnetic field created by a magnet, the magnetic field linked with the coil keeps changing. And when the magnetic field linked with the coil changes, a current flows. Okay. Now, the current that flows depends on how much it is made to vibrate. And how much it is made to vibrate depends on the sound we are producing. So if it is like where your volume is very low, you're talking very softly to the microphone, the amount of current produced will be proportional to that. If you're screaming on top of your lungs into the microphone, again, the current produced will be much higher compared to the amount of current produced previously. So all your sound waves, what is happening in a microphone? All your sound waves are being converted into electrical signals. So what's happening there? The sound waves are being converted into electrical signals. And the strength of the signal will then depend on the amplitude of your sound. Okay, so that is basically how the microphones work. So if I repeat, they work using the principle of electromagnetic induction. So when sound waves are produced, they vibrate the diaphragm. The diaphragm vibrates, vibrating the coil attached to it. The coil keeps vibrating in a magnetic field, or the magnetic field linked with the coil changes and a current flows through the coil. Okay, and microphones convert sound energy into electrical energy. So I hope the concept of microphone is clear to you. As I said in the other PowerPoint, I will email you all these PowerPoints so that if you want to make a note of anything, you can always do that. Okay, so all okay with microphone? In that case, I'll move on to the next one, which is a loudspeaker. So try to compare microphone and loudspeakers. What happens in a microphone? You're giving sound energy to it. In a loudspeaker, what happens? You're getting sound energy from that. So I'm going to give you a minute so that you can copy anything you want to. Don't worry about the diagram. It is there in the green book that we have given you. So take a minute, copy the main points, and then we will move on. Okay, in case if you want to write it, you can, if there is any slides you want to go back and copy, you can always ask the teacher in the class to go back later on. Okay, so we are moving on to the next one. So finally, we are moving on to loudspeakers. So loudspeakers, you know, as the name suggests, and you are very much familiar with the loudspeakers, it produces sound. Now, how does it produce a sound? The setup looks very much similar to a microphone. You can see a magnet, you can see a coil of wire, and all those things here also. So we said microphone works on electromagnetic induction, right? Loudspeakers work on motor effect, which is the opposite of electromagnetic induction. So what happens here? So you have already used the microphone. For example, say you are singing. you are singing and the microphone has converted your voice, your sound, to electrical impulses. These electrical impulses, or this current, then goes through this coil, as you can see here. And when current flows through a coil, what happens? It creates a magnetic field. There is already a permanent magnet here. So both the magnet fields are going to interact and it's going to produce a force. And that force is going to make the cone attached to the coil to vibrate. You can see a cone here. So the force produced makes the cone vibrate. And you have studied in your lower classes, how is sound produced? Sound is produced by the vibration of objects. So this vibration of the cone produces the sound. Now, how we send these electrical signals are AC. So that is what makes the cone vibrate forwards and backwards. So in short, the electrical signals sent to the coil produces a magnetic field which interacts with the magnetic field of the permanent magnet and produces a force. This force makes the cone inside the loudspeaker vibrate, and which in turn produces sound. So this is how loudspeakers work. Okay, so make a note of it, and then we are almost there. So I'll give you a minute to make a note. So year 11s, with this we have theoretically we have reached the end of P4, but next week I'm hoping to be in school. So if you have any questions or concerns that time regarding the topics we have done so far in magnetism, we can use a couple of lessons to go through any doubts you have. Okay, so to summarize this lesson, so you have two applications. One is loudspeaker and one is microphones. So one of them works on motor effect and the other one works on electromagnetic induction. So it starts with a microphone because you have to talk into the microphone. So what do microphones do? They convert sound energy to electrical energy. Loudspeakers do the opposite. Loudspeakers are given electrical energy, you get sound from it. Microphones are given sound energy, you get electrical energy from it. So when you give sound energy, when you produce sound waves, it makes the diaphragm of a microphone to vibrate, which then makes the coil move in a magnetic field. The magnetic field linked with the coil changes, so that induces a current. So whatever sound energy you're giving to it, the microphone produces current proportional to that sound energy. And since the microphone moves forwards and backwards, the current produced will also keep changing direction, or you get an AC there. This electrical energy produced there, or the AC produced, is then it goes to the loudspeaker. So in the case of a loudspeaker, it is then what is happening? Motor effect is happening. The current flowing through the coil in the loudspeaker produces a magnetic field. The magnetic field interacts with the magnetic field of the permanent magnet, producing a force. This makes the cone in the loudspeaker to vibrate, and then that produces sound. Okay, so that is a summary of loudspeaker and microphone. So now, once we are done with this, you need to move on to your green book and go to loudspeaker and the microphone part of it and read through the notes which is given to you there. And if there are any questions with it, continue with the questions also. Okay, so that is all for the time being now. I'll send you the PowerPoints in case you need to look into it again. Okay, 11, hope to see you next week. Bye-bye.